Assalamualaikum warahmatullahi wabarakatuh and a very good day to Madam Rosianiwati. Today, we are Group 2 from N4 CS249 3B1 would like to present to you about our project for data mining subject ISP565 with the title Prediction of Hypothyroid Disease. Before that, let me introduce you our group members. Firstly, it's me, Nadia Shakirah binti Muhammad Zain, and my student ID is 2022931085.
Next, my name is Nur Sofiatul Nadirah binti Abdul Razak. My matrix number is 2022780519.
Next, my name is Nur Shuhada binti Nasib and my student ID is 2022917659.
I am Nur Fatim Farana binti Zaid. So now, I will be briefing first about the background of this disease and this group project. Thyroid problems are becoming more widespread over the world, harming health in a variety of countries. This ailment is distinguished by the fact that it affects many capacities of the human body, directly altering the living conditions of those who suffer from it. Globally, the use of technology in the area of medicine has enabled the tracking of the behavior of many disorders or diseases, and in some circumstances, the prediction of when a person may or may not suffer from any of them. With the emergence of artificial intelligence, several academics and professionals have concentrated their efforts on using it as a tool to help improve the physical condition of the world's population in order to enhance people's health conditions and so provide them with a better quality of life. Hence, for this project, we will be using WEKA Environment for Knowledge Analysis or WEKA Software in order to detect whether a person has hypothyroid disease or not. Then, what is thyroid and hypothyroid? First, thyroid is a small butterfly-shaped gland in everyone's neck, just in front of the windpipe, trachea. It produces hormones that affect things such as our heart rate and body temperature. Then, what is hypothyroid? Hypothyroid is a condition when the thyroid gland does not produce enough of certain crucial hormones. This makes your metabolism slow down, also called underactive thyroid. Hypothyroidism may not cause noticeable symptoms in the early stages. Over time, untreated hypothyroidism can cause a number of health problems such as obesity, joint pain, infertility, and health disease. Like in this illustration, you can see the right one. The thyroid looks like a swollen compared to the left one, which healthy thyroid. Next, for symptoms of hypothyroid and hyperthyroid, both of the diseases give different symptoms. Like for the hypothyroid, ones who get affected will feel fatigue, depression, impaired memory, impaired concentration, and mental fog, or other words, confusion, forgetfulness, and a lack of focus and mental clarity. Meanwhile, for the hyperthyroid, they will feel anxiety, nervousness, irritability, and insomnia. In terms of physical factors, for hypothyroid, they will get puffy face, slow heartbeat, gain weight, and constipation, while for the hyperthyroid, it is opposite of hypothyroid. They will get bulging eyes, lose weight, diarrhea, and rapid heartbeat. And both hypothyroid and hyperthyroid patients will lose their hair, changing at their goiter, and facing infertility. Now, let's proceed for project tasks. First and foremost, we will start for A1, which data acquisition and data understanding. Let's move on to problem statement for this project. In order to complete this assignment, my group need an accessible and user-friendly tool for the end user to check and predict on patient who is diagnosed with hypothyroid disease. Hence, all the data that we got, we obtained from UCI Machine Learning repository. For objective, as I said before, this project we will analyze which classification model will work the best to predict whether the patient have hypothyroid disease or not. From the dataset information that we get in UCI, we have 3,163 number of instances, 26 number of attributes, while the type of data is nominal and numeric, and we have missing values. And to conduct this project, we are using classification method. Hence, we have met all the necessary criteria in this project assignment. Next, I will show you the list of attributes in our dataset. 1. Age and the data type is numeric. Next, sex, on tyrosine, query on tyrosine, on anti-thyroid medication, thyroid surgery, query hypothyroid, and pregnant. And all the attributes have nominal data type. Then we have sick, tumor, lithium, goiter, TSH measured, T3 measured, and TT4 measured. And all of that is nominal data type. Meanwhile, for TSH and T3 is numeric data type. Please be noted that TSH is stand for thyroid stimulating hormone and T3 is tridothyronine. Both of them is type of thyroid hormones and have numeric data type. And the last list of attributes, we have TT4, T4U, FTI, TBG and class. All of them is classified as numeric data type. Meanwhile, for T4U measured, FTI measured, TBG measured is nominal data type. Then, same like before, be noted that TT4 is tyrosine, T4U is tyrosine utilization rate, FTI is free tyrosine index, TBG is tyrosine binding globulin. All of them are the crucial terms in hypothyroid disease. Last but not least, for A1, dataset with attribute and possible values. Since thyroid disease classification uses dataset extracted from the UCI machine learning, the hypothyroid dataset are used for the research and development department for experimental purposes. The dataset contains 3,163 instances. In this 149 data comes under hypothyroid and 2,941 data is negative cases. In total, it has 25 features which are distributed as follows. 7 continuous variables and 18 categorical variables contains true or false which are used for classification of thyroid.
A2 data preparation, selection and cleaning. First, data information. Numeric attributes in this data have 7 attributes. First, we have H attribute, TSH, T3. Next, we have TT4 attribute, T4U attribute, FTI. And lastly, we have TBG attribute. Next, for the nominal attributes, we have 19 attributes. For the nominal attributes, first, we have sex attributes, on thyroxine, query on thyroxine, on anti-thyroid medication. Next, thyroid surgery, query hypothyroid, query hyperthyroid, and pregnant. Next, sick, tumor, lithium, and goiter. Next, TSH measured, T3 measured, TT4 measured, T4U measured. Next, FTI measured, TBG measured, and lastly, class attribute. First, before we start to clean our data, we need to set our class target. In our data, we want to set the class attribute as our class target. To set it, first we click on Edit, then right-click on the class attributes, then select attributes as class. As we can see, the class attribute is already set as the class target of the data. Then we click OK. Next, attributes with missing values. For the numeric attributes, first we have age with missing values 446 or 14%. Next, we have TSH with missing values 468 or 15%. Next is T3 with missing values 695 or 22%. TT4 with missing values 249 or 8%. Next, T4U with missing values 248 or 8%. FTI with missing values 247 or 8%. And lastly, for the numeric attributes, we have TBG with missing values 2,903 or 92%. For the nominal attributes, we have sex attributes with missing values 73 or 2%. So, how to deal with the missing values attributes? First, we select choose, then we select filters, then unsupervised attributes, then we find the replace missing values. We did not change anything in the properties, and lastly, we apply. As we can see, all the attributes that have missing values earlier is already becoming 0 or 0%. For example, the 3 attribute which earlier have 695 missing values, but now it becoming 0 missing values or 0%. Next, attributes with containing noise. What it is actually mean by attribute with containing noise? To know that one attribute containing noise is we observe it at the distinct. If the attributes have a large amount of distinct, then that is mean that attribute is containing noise. In our data, the attributes that containing noise is first, TSH attribute which contain distinct of 220. Next, TT4 attribute which contain distinct of 225. Next, T4U attribute which contain distinct of 123, and lastly FTI attribute which contain distinct of 233. So, how to deal with the attributes that contain noise? We handle it with the discretization process, which are process of transforming numeric attributes to nominal attributes, and will be explained deeply in A3 section. Lastly, in this section, attributes with outliers. Firstly, to check if there is outliers in this data, we select choose, filter, unsupervised, attributes, and find interquartile range. We did not change anything in the properties, then we apply it. As we can see, there is new attributes which are outliers and extreme values. Now, in the outliers attributes, we can see that there is 225 outliers in this data. Then, in the extreme values attributes, there is 225 extreme values in this data. So, how to deal with all the outliers that we have in this data? To remove it, first we select choose, filters, unsupervised, instances, and then find remove with values. In the properties, we change the attribute index to 27 because the outliers attributes is the 27th attributes. Then the nominal indices section, we change it only to last because we only want to deal the instances that have outliers in this data, or for easy understanding, in the outliers attribute, we want to delete the yes part only, not both instances that have or do not have the outliers in this data. Next, for the extreme values, we did not change anything because usually extreme values does not affect our data. And lastly, we delete both outliers attributes and extreme values attributes by select it and remove it. Then I save the clean dataset into file clean.arff. And lastly, this is the samples in the dataset after cleaning it.
So I will continue with A3 data preparation transformation, which consists of normalization, discretization, and attribute construction. For the first process in data transformation is normalization process. Normalization process is important as it is to get rid of a number of anomalies that can make analysis of data more complicated. Normalization filter usually used for normalize the numeric attribute. There are three types of normalization, which are min-max normalization, z-score normalization, decimal normalization. For the min-max normalization is a common way to normalize data where the filter set the mean value to 0 and max value to 1, and the others value will transform to decimal value between 0 to 1. These features guarantees all the features to have exact same scale. Z-score normalization is a strategy of normalizing that the data avoids this outlier issue. It also handles outliers but does not produce normalized data with the exact same scale. Decimal normalization is a filter, whereas it moves the decimal point of values of the attribute. So for our dataset, we choose min-maximum normalization. This is because we want to transform the minimum values to 0 and the maximum values to 1, and others value get transformed into a decimal between 0 and 1. So how we apply this process? We need to choose filter and then unsupervised and then attribute and normalize. So there are 7 attributes that we will normalize, which are age, TSH, T3, T4, T4U, FTI, and TBG attribute. So for the upper image is before we do the normalization for age attribute. As you can see, the mean value is 1 and the max value is 98. It has a big value, so after we apply the normalized filter, the min max value will change to 0 and 1, while other values change to decimal point between 0 and 1. Same goes with TSH attribute, T3 attribute, T4 attribute, T4U attribute, FTI attribute, and TBG attribute. Next is discretization process. Discretization is the process of putting value into buckets so that there are a limited number of possible states. Discretization can be used to divide the range of continuous attribute into interval. For our dataset, we will discretize 4 attributes, which are THH, TT4, T4U, and FTI attributes. Why we choose these 4 attributes? Because there have highest distinct values than others. For apply the discretization process, we will click choose and click filter, and then we click unsupervised and click discretize. For the properties, we set the attribute indices to 15, 19, 21, and 23. And the bins we change to 3 because I want to implement only 3 bins for the data set, and we can press OK. So we apply it. So the upper image is a data set before we apply the discretize filter for THH attribute. As we can see, the data set remains the same value, which consists of minimum, maximum, mean, and standard deviation value. And the distinct is very high, which is 220. And for the below image is a data set after we discretize. So we can see that the level was divided to 3 bins or 3 distinct, and the type of attribute changed to nominal. So it same goes to TT4 attributes, T4U attributes, and FTI attributes. So we can see the upper image is before we discretize, and the below image is after we discretization and before we naming and labeling the label. Next, for this image are the steps for naming and labeling dataset manually using Excel. First of all, the dataset is we save in CSV format, and then we open the dataset in the Excel, and then we click on find and select, which is the icon is magnifying glass on the right side, and then we select one class label for this image. So I choose in negative infinity to 0.333, and I copy the label and paste it on the find what. After that, I click on replace with, and I replace the label with low. So all the label with negative infinity to 0.333 we replace to low. For this image, I select one class label, which is 0.33 to 0.667, and then I copy the label and paste it on the find what. After that, I click on replace with, and I replace with the label with normal. So all the label with 0.33 to 0.6667 will replace to normal. So for the last image on Excel, I choose for the last image on Excel process, I select one class label for this image. So I choose 0.6667 to infinity, and I copy the label and paste it on the find what. After that, I click on replace with, and I replace the label with high. So all the label with 0.6667 we replace to high. So these are the output after we naming and labeling. So we can see the negative infinity to 0.33 change to low, and 0.333 to 0.667 to normal, and lastly for the 0.667 to infinity to high. So that's all for discretization process. Next is attribute construction process. Attribute construction is to construct new attributes out of the original one, transforming that original data representation into a new one where irregularities in the data are more easily detected by the classification algorithm, which tends to improve the predictive accuracy of the latter. In our dataset, we do apply attribute construction because we want to improve the predictive accuracy of the dataset. So we choose 5 attributes in attribute construction to become 2 new attributes, which are query on tyrosine, query hypothyroid, query hyperthyroid, quadrant, and 2 more attributes. So to apply attribute construction, we need to choose filter unsupervised, and then we click attributes, and then we click add expression. So in the properties, we choose the expression with operation like addition or subtraction, and the name we can change to any name we want. This image shows the data set before we apply attribute construction process. So we have 26 attributes. So how we apply attribute construction? Firstly, we choose filter and then unsupervised, then attribute, and we click add expression. So for the first attribute construction in the properties, I change the expression to 4 at 7 at 8 with query on tyrosine, query hypothyroid, and query hyperthyroid. So for the name, we change to query. So I click OK, and then I click apply. So the result is the output after we apply for the first attribute construction. So there is a query attributes. So next for the second attribute construction, we just change the properties which are for the expression, we change to 11 plus 13, which tumor and goiter. So for the name, we change to symptoms. So we click OK and then we click apply. So there's the result is the output after we apply the attribute construction. So we can see there's our query and symptoms attributes. After that, we remove the 5 attributes that we have been combined by manually. So we click the left side of the 5 attributes and we click remove for the selected attributes. Next, for this image shows the attributes after we remove and did the attribute construction, which are 23 attributes only. So these are 20 rows of these data sets with all columns after attribute construction.
I will be presenting section B in A3, which is data preparation before reduction. In this study, the algorithm that we use is classification. Now, I am going to explain about the J48 classification which we already used to classify different applications and perform accurate results. The first test is with the cross-validation K for 10. For the full data set, it produced the accuracy of 96.73 to 5% and the incorrectly classified is 3.2675%. For the total confusion is 2,842. For the confusion matrix, 37 is classified for people diagnosed hypothyroid disease and 2,815 is for negative, which people doesn't diagnose hypothyroid. Second test is for J48K for equal to 20. The dataset produced 96.6984% for correctly classified and 3.3016% for incorrectly classified, while the total confusion is 2,841. Okay, from the both tests that we conducted, we know that the best result of 3 visualizer for cross-validation is K for 10. It is because the accuracy in K10 is greater, which is 96.7325% than K for 20, which 96.6984, with the only 0.0349% higher than K for 20. Now, let's move on to the third test. It's the percentage split of training 70% and testing 30%. It is produced the full data set for the accuracy is 96.3678% and the incorrectly classified is 3.6322%, while the total confusion is 849. And for the last one is for the percentage split for training 80% and testing 20%. It is produced the accuracy of 97.449% and incorrectly classified with 2.551%, and the total confusion is 573. Hence, from the both tests that we conducted, the best result of 3 visualizer for percentage split is with the ratio 80:20. It is because the accuracy for 80:20 is more higher, which have 97.449% than the ratio for 70:30, which is 96.3678, with only 1.0812% higher than ratio 70:30.
Moving on to A4, data preparation, which is reduction.
As you can see, there are 23 attributes before we do reduction. These are the list of attributes that we have.
This is the result of attributes using ranker. We want to remove the least important attributes to improve the accuracy. Hence, we reduce the attributes one by one, starting from bottom.
Next, this is the list of attributes that we got after we do the reduction. From 23 attributes, it becomes 15 attributes. We remove these attributes by clicking this remove button. And it will become like this.
This is the screenshot showing the list first 20 rows of this dataset. Cross-validation with false K equal to 10, the accuracy that we got is 96.6644%. Next, for the cross-validation with faults k equal to 20, accuracy that we got is 96.5623%. In addition, for percentage split with ratio 70-30, the accuracy that we got is 96.9353%. Then, the percentage split for ratio 80-20, the accuracy that we got is 97.2789%. The best result of tree visualizer for cross-validation is with faults k equal to 10. It is because the accuracy in k equal to 10 is greater, which is 96.6644, than faults k equal to 20, which is 96.5623. The best result of tree visualizer for percentage split is with ratio 80-20. The reason is the accuracy for 80-20 is higher, which is 97.2789, than ratio for 70-30, which is 96.9353. In conclusion, this is the comparison of processed dataset and after the dataset is reduced. Firstly, we take a look at the cross-validation with faults k equal to 10. It shows that accuracy after we do the reduction is higher than the before, which is 96.9367%. Next, the cross-validation for faults k equal to 20, it shows that the before is higher than the after we do reduction, which is 96.6984%. Next, for percentage split, it shows that we got the higher accuracy when we do reduction, which is 96.9353%. Lastly, for percentage split 80%, we do not need to reduce to get a higher accuracy, which is 97.449. Besides, the accuracy is decreased because there are some attributes that we remove are important to it, but we proceed to remove it till the accuracy do not drop. Hence, for the cross-validation with k equal to 20 and percentage split 80-20, the highest accuracy is when before we reduce it. That is all from us. Thank you for watching.